Hi, my name is Joost. I'm an engineer to WCOM, and in this little video I want to show you how to set up mpeg FEC to protect your encoder to decoder streams. Unlike RISC, which we explained in a different video, the mpeg FEC is a forward error correction. That means that the encoder will just send the data, but the decoder will not report back to the encoder. So it is a fire and forget error protection sort of. So in order to set up a mpeg FEC for your encoder output, just hit edit and enable it over here. You have different options what you can set up. Basically, the encoding matrix size, we offer 4 presets: 1x4, 4x4, 5x5, and 10x10. The major difference in between all these matrices, the larger they get, the less overhead you need to send. But you also need to increase the delay on the decoder for it to be able to recover any packet gaps or packet losses. And then you set up the ports for the row and column streams. So there will be row and column packets that protect the row or column they're being calculated over. And those are sent as individual streams with using the port offset 2 and 4 by default, which is so the first stream goes out to 5004 plus 2, so 5006 and 5008. And also keep in mind, as with all RTP streams, those streams as well carry RTCP packets, so you need to have ports +3 and +5 enabled as well in order for encoder and decoder to exchange information. So once we set it up on the encoder, we head over to the decoder, go to the input, edit it, and we just enable it here as well, using the same offsets you configured on the encoder. Save. Now on the overview page, you have a new information block for the FEC, and it will tell you what matrix size is being used, how many recovered, unrecovered packets you have, the bit rates for the column and row packets, and the packet error rate. I will now throw away every 100th packet, and we'll just monitor what will happen. So you can see that the IP input statistics sees that there's 1 packet missing, and the FEC has restored it. Now it's the second packet missing and recover 2 packets. So we effectively were able to recover all the packets. Of course, if the packet loss goes higher, at some point the FEC won't be able to close all the gaps. But overall, it's very efficient against sporadic packet loss and also small burst error losses. As with other RTP streams, you can also go back to the encoder and watch the stream statistics on the encoder output. It will also carry how many packets were lost, which is being reported back to the encoder. But unlike with RISC, which is a different error protection scheme we offer, here you won't be able to tell if all the lost packets have been restored or not. Because it's a forward error correction, it's fire and forget. So even if you don't have a back channel, it will still work. And that pretty much concludes this part.